In this video, we are going to find the intervals on which a function f is increasing or decreasing. Then we're going to find the local maximum and minimum values of that function f. And lastly, we're going to find the intervals of concavity and the inflection points of f. So here we have that f of x equals sine of x plus cosine of x, where x is ranging between 0 and 2 pi. So first, we'll find the intervals on which f is increasing or decreasing. To do that, we need to take the derivative of the function f and set it equal to 0. That'll allow us to find the critical numbers. So let's do that. First, we'll recall two things. The derivative of sine of x is cosine of x, and the derivative of cosine of x is minus sine of x. So what is the derivative of sine of x plus cosine of x? Well, that's just going to be the derivative of sine, which is cosine of x, plus the derivative of cosine, which is minus sine of x. Okay, so this is f prime of x. Now we want to set this equal to 0 and find the values of x that allow this to happen. So I can add sine of x to both sides and get cosine of x equals sine of x. Now what does that tell me? That tells me the values of x for which cosine of x equals sine of x are the critical numbers. Now, how do I know which values of x satisfy this? Well, what I like to do is draw the unit circle. Okay, so when on this circle does cosine of x equal sine of x? Well, here we have that cosine of x equals sine of x. In particular, this point is root 2 over 2, comma root 2 over 2. And the angle at which this happens at is the angle pi over 4. Now, where else are cosine of x and sine of x equal? Well, they're also equal directly across over here. So we have that this point is minus root 2 over 2, comma minus root 2 over 2. And then this angle here is the angle 5 pi over 4. Okay, great. So this tells me that x is equal to pi over 4 and 5 pi over 4. So these are the critical numbers. And in order to find where f is increasing or decreasing, we need to plug certain values into the derivative and see if the derivative is positive or negative. So what I like to do is draw a number line. And so x has to be between 0 and 2 pi. So I'm just going to put 0 here and 2 pi here. Now the values of x that we just got, the critical numbers, are pi over 4 and 5 pi over 4. So I plot the critical numbers on this number line. And now basically I want to take a number in each interval. So here we see we have 3 intervals: the interval from 0 to pi over 4, the interval from pi over 4 to 5 pi over 4, and then the interval from 5 pi over 4 to 2 pi. So I want to take a number in each interval and plug it into the derivative. And I don't care exactly what the value is. I just care about whether the value of the derivative is positive or negative at that point. So in between 0 and pi over 4, what's an angle that we know that we can easily compute sine of that angle and cosine of that angle? Well, somewhere over here is the angle pi over 6. So we can use that value. And then in between pi over 4 and 5 pi over 4, we have over here pi over 2. So we can use that angle. And then between 5 pi over 4 and 2 pi, we can use the angle directly below, which is 3 pi over 2. So now what am I plugging these values into? I'm plugging them into the derivative of f, because wherever the derivative is positive or negative is going to tell me whether the function f is increasing or decreasing on that interval. So let's start plugging things in. So first I'll do f prime of pi over 6. So what is that going to be? That's cosine of pi over 6 minus sine of pi over 6. And so that's going to be root 3 over 2 minus 1/2. We don't need to know exactly what that is, but we know that root 3 is greater than 1, so this is going to be greater than 0. This is going to be positive. So on the first interval from 0 to pi over 4, we have that f prime is positive. And I can put f prime here, so we know that this is telling us what the sign of f prime is. Next, we want to check f prime of pi over 2. So that's going to be cosine of pi over 2 minus sine of pi over 2. So at pi over 2, cosine is 0 and sine is 1. So we have 0 minus 1, that's minus 1. The point is it's less than 0, which means it's negative. So on the interval from pi over 4 to 5 pi over 4, we have the f prime is negative. Lastly, we want to plug in 3 pi over 2. So we have cosine of 3 pi over 2 minus sine of 3 pi over 2. So what is that? Cosine of 3 pi over 2 is 0, and sine is minus 1. So we have 0 minus minus 1, which is 0 plus 1. So this is greater than 0. It is positive. So that means that from 5 pi over 4 to 2 pi, we get that the derivative is going to be positive. Okay, now how can we use this information to determine where f is increasing or decreasing? Well, the intervals for which f prime of x is greater than 0 are the intervals for which f is increasing. And then the intervals for which f prime of x is less than 0 are the intervals for which f is decreasing. So, given this information, what can we say? Well, f is increasing on the first interval, 0 to pi over 4, and the third interval, 5 pi over 4 to 2 pi. Okay, now where is f decreasing? Well, f is decreasing on the middle interval where f prime is negative. So that's going to be from pi over 4 to 5 pi over 4. Great, so this answers part A. So we found the intervals on which f is increasing or decreasing. Now part B asks us to find the local maximum and minimum values of f. Okay, so what do we know about the local max and min? Well, if our derivative goes from being positive to negative, that means that we go from positive to negative, which means that this point is going to be a local max. If my derivative goes from being negative to positive, so it looks like a dip, this is going to be a local min. So using that knowledge of what we have drawn up here, what can we say about where there's a local max or min? Well, first we have the derivative going from positive to negative, and that change occurs at the point x equals pi over 4. So that means that pi over 4 is going to be a local max. So there's a local maximum at x equals pi over 4. Now, what's that point going to be? Well, I can just plug that into f. So f of pi over 4. Now remember, my function f is sine of x plus cosine of x. So this is sine of pi over 4 plus cosine of pi over 4. So this is equal to, sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is also root 2 over 2. So this is 2 root 2 over 2. And we see these 2's cancel out. So I'm left with root 2. Okay, great. So there's a local maximum at the point pi over 4, comma, root 2. Okay, another way we can write this is f of pi over 4 equals root 2. So that's a local maximum. Now going back to our number line, we see that the derivative goes from being negative to positive, and that change happens at the point 5 pi over 4. So that's going to be a local minimum. So we have local minimum at x equals 5 pi over 4. Now again, I want to know what that point looks like, so I'm going to plug it into f. So this is sine of 5 pi over 4 plus cosine of 5 pi over 4. So this is equal to minus root 2 over 2 plus minus root 2 over 2. So this is minus 2 root 2 over 2. So we can cancel out the 2 from the numerator and denominator, and we're left with minus root 2. So this local maximum is f of 5 pi over 4 equals minus root 2. Great, so we found that there's a local maximum at this point and a local minimum at this point. Great. So now the last part of this problem asks us to find the intervals of concavity and the inflection points. So whenever you see concavity or the words concavity or inflection points, you should think second derivative. So basically what we want to do is find the second derivative of f and then do the same exact things we did for finding the intervals on which f is increasing or decreasing, except we do this for the second derivative. So what do I mean by that? Well, okay, first we got that the first derivative is cosine of x minus sine of x, so let me rewrite that here. Oops. So we have f of x equals sine of x plus cosine of x. We already computed the first derivative, which we said was cosine of x minus sine of x. Now we want to take the second derivative. So that's going to be the derivative of cosine, which is minus sine of x, minus the derivative of sine, which is cosine of x. Great, so now what I want to do is set this equal to 0. And so if I do that, I can add cosine of x to both sides, so I get sine of x equals cosine of x. Now what does that tell me? That tells me that the values of x for which minus sine of x equals cosine of x are, I guess you can call them the critical numbers, and they're the potential inflection points. We actually have to see what intervals the function is concave up or down to see if that point actually is an inflection point. But these are the important values we want to check. So when does this happen? Again, I'm going to draw my unit circle. Okay. So basically you can think of this as one are sine and cosine equal, but one is negative and one is positive. Well, that happens over here, right, where we have cosine is minus root 2 over 2 and sine is positive root 2 over 2. And so that angle is 3 pi over 4. And the other place that happens is directly across from there, here, where we have cosine is root 2 over 2, but sine is minus root 2 over 2. And that angle here, it's a little harder to draw, but this angle is 7 pi over 4. Great, so we found the important values and we can plot them now. So again, remember that x ranges from 0 to 2 pi, so I'll just put 0 and 2 pi here, and then I'll plot 3 pi over 4, and then 7 pi over 4. And again, we have 3 intervals, the interval from 0 to 3 pi over 4, the interval from 3 pi over 4 to 7 pi over 4, and then the interval from 7 pi over 4 to 2 pi. So I'm going to choose a value in each of these integrals and then plug it into the second derivative to see if the second derivative is going to be positive or negative at that point. So what values can I choose? Well, between 0 and pi over 3, I can choose this value here. That's pi over 2. Between 3 pi over 4 and 7 pi over 4, I can just choose the angle directly across from pi over 2, which is 3 pi over 2. Now between 7 pi over 4 and 2 pi, this is a bit trickier, I can choose this angle here, which is the angle 11 pi over 6. Now I'm going to plug this into my second derivative to see what I get. So first, let's plug in pi over 2. So that's going to be minus sine of pi over 2 minus cosine of pi over 2. So what is that? That's going to be minus 1 minus 0. So that's negative. So between 0 and 3 pi over 4, we get that the second derivative is going to be negative. Now let's plug in 3 pi over 2. So I have minus sine of 3 pi over 2 minus cosine of 3 pi over 2. So what are these values? That's going to be minus 1 minus 0. So that's just 1, which is positive. So we're going to be positive on the second interval. Now the last value we want to plug in is 11 pi over 6. So minus sine of 11 pi over 6 minus cosine of 11 pi over 6. That's going to be minus negative 1/2 minus root 3 over 2. Now minus 1/2 is just positive 1/2, and then we're subtracting root 3 over 2, and root 3 is larger than 1. So this is going to be negative. So we get negative on the last interval. Okay, so what does this tell me about where f is concave up or down? Well, if the second derivative is positive, then f is concave up on that interval. And if the second derivative is negative, then f is concave down on that interval. So based off of what we just did, this tells me that f is concave up on the interval 3 pi over 4, 7 pi over 4. Great. And then this tells me that f is concave down on the interval from 0 to 3 pi over 4 and the interval from 7 pi over 4 to 2 pi. Great. Now, the last thing we wanted to find was the inflection points. So the inflection point is when the second derivative goes from being negative to positive or positive to negative. If the second derivative goes from being negative to negative or positive to positive, that is not an inflection point. So here we see that the second derivative goes from being negative to positive at x equals 3 pi over 4. So for inflection points, we know there's going to be one at x equals 3 pi over 4. So we can plug that into f to see what that coordinate is actually going to be. So f of 3 pi over 4, remember the function f is sine of x plus cosine of x. So this is sine of 3 pi over 4 plus cosine of 3 pi over 4. And what is that? Well, at 3 pi over 4, we have that cosine is root 2 over 2, and cosine is minus root 2 over 2. So that equals 0. So here, f of 3 pi over 4 equals 0. Now, that's one inflection point. Now we also have that the second derivative goes from being positive to negative at the point x equals 7 pi over 4. Okay, so x equals 7 pi over 4 is going to be an inflection point. So if we plug that into f, let's see what we get. Well, at 7 pi over 4, we have that sine is minus root 2 over 2, and cosine is root 2 over 2. So this is also 0. So f of 7 pi over 4 equals 0 is the other inflection point. And so now we basically found everything the problem was asking for. Can scroll back up to double check. It's a lot of work. Okay, so first find the intervals on which f is increasing or decreasing. So to do that, we find the first derivative of f, set it equal to 0, and find the critical numbers. Then we plot those and plug certain values in to the first derivative to see which intervals the function is increasing or decreasing on, or in other words, to see where the derivative is positive or negative. That gives us the intervals for which f is increasing or decreasing. Then to find the local maximum and minimum values, we just check to see when the function f goes from increasing to decreasing. And so by doing so, we were able to find the local maximum and the local minimum. And then the last part was asking us to find concavity and points of inflection. So that requires us to take the second derivative of the function, set it equal to find the important values of x, and then we do the same thing where we make a number line and we plot values in between those numbers to see where the second derivative is positive or negative. In doing so, we're able to find the intervals for which the function is concave up and concave down. And then by looking at where the function is concave up and concave down, we're able to find the inflection points. If this video was helpful, feel free to like and subscribe.